to our third activity of our educational trainer kit series. So today's experiment is button plus relay activity. In the previous video we have seen the two activities, that is LED plus button activity and LED plus buzzer activity. In this we will see how pressing a small button can control a relay which is used to switch on or off the real electrical appliances safely. So the objective of this activity is to understand how a microcontroller interfaces with a relay and how a simple input can control large electrical loads. So in this activity, the relay is taken as output devices and this push button is taken as input devices. Now let's understand the circuit of this activity. The push button is connected to digital input pin of a microcontroller and the relay module is connected to one of the digital output pins. So when the button is pressed, the microcontroller sends high signal to the relay which energizes the coil, and then the relay acts as a switch, allowing current to flow the connected load. And when the button is released, the signal goes low and the relay deactivates and load turns off. Now we will do coding for this activity. And here this is the code for this activity and these are the pin connection of this activity. So if you are using another code, then check the connections and make the connections as this interfacing. So now we will select the board, which is Arduino Mega 2560, and select the port COM7. I have selected here COM7, and after this upload the code. After uploading the code, we will see how it works. When we press the first button, first relay is on. When we press the second button, the second relay is on. When we press the third button, the third relay is on. And when we press the fourth button, the fourth relay is on. And see how it works. This is our third activity. Now let's do our fourth activity, which is button motor driver activity. In this activity we have used L293D IC. This is our motor driver IC, which is a very powerful component that acts as a bridge between the microcontroller and the motor. Why do we need it? Because a microcontroller cannot supply enough current to run a motor directly. That's where the motor driver comes in. It takes small control signals and delivers that require power to drive motors. To understand how microcontroller controls DC motor using motor driver IC and how we can change motor direction and speed. So in this activity we have used the L239D motor driver IC, the BO motor and the microcontroller on the trainer kit board. So the L239D is like a traffic controller for current. It directs electricity to flow into the motor in one direction for forward motion and reverse it for backward motion. It works on the H-bridge principle, where switches decide the direction of current through the motor. Logic 1 plus logic 0, motor runs forward, and logic 0 plus logic 1, motor runs backward. And when logic 0 plus logic 0, the motor stops. Now we will upload code for this activity. In the code there are given 4 motors, motor 1, motor 2, motor 3 and motor 4. But we are using only one motor for the demo. So apply the same process, select the board and select the port and then upload the code. And if you are using another code, then apply the same process and check the interfacing as per trainer kit. After uploading the code, we will see how it works. The motor turns in forward and backward direction and then stop. From this activity, we learn how to control DC motor safely using motor driver. It's the foundation for building robotic cars, conveyor belts, and automated machines. The L293D IC is the unsung hero that turns digital signals into real movement, and that completes our motor driver activity, where small commands bring big motion. In the upcoming activities, we will push these ideas further into sensors and smart automation. So this is our fourth activity.